So we start with this template, and what this template does is just load a window, and when you click on the small button here, it just quits. So how does this work? Well, first we load the PyGame module like this. So that module must be installed. You can install it with pip, or depending on your programming environment in PyCharm, you can install it as a module. Then your entry point is always main, in which we create a new game object from the class game, and we execute that. So what does this game class do? Well, it sets the variable running to true, and it initializes PyGame. You'll see here pygame.init. Then it creates a window with this line where it sets the width and height. So this is the width in pixels and height in pixels. It instructs to use hardware acceleration. It sets the window title, and again we set the variable running to true. And we already did that, so we can essentially remove that. Then we have a render function which just clears the screen. So in red, green, blue values, everything's 0, so it's a black screen, and this updates the screen. We have a quit function, and this is the actual loop. So it starts here. If it's not initialized, it breaks. So while the variable running is true, goes over the events. Now an event is, for example, anything the user inputs. So that can be a key press or a mouse press. In this case, you want to be able just to click the little cross. So if you load the program, you want to be able to click this cross. If that event occurs, it'll set running to false and quit. Now, while it's in the running loop, it calls the onRender function. So it repeatedly clears the screen and updates the screen. Next, we can load an image. So we can load an image like this. The image should be in the same directory as your program. So in this case, we have a cat image here in the same directory as our Python programs. Otherwise, you need to specify the path, the relative paths, or the hard-coded path. So you can load an image by calling pygame.image.load, and don't forget to add convert. So this loads an image into a sprite. Now I've named it cat image. And then you can draw it by calling the .blit method on your display surface, and then specify the image you want to use and the position. So this is the horizontal and vertical position. If we run the program, you'll see the position is at 0, 0 in the left top. Now you can move it around if you change these values. For example, set it to 100 by 100, and that will move it by 100 pixels on vertical and horizontal position. That can be anywhere on the screen, just within the limits of this window resolution. So if you see it's 640 wide. So if you were to set it at 600, most of the image will be outside of the screen. So you see, you can't really see it now. So you wanted to set it somewhere inside the screen. Now it's horizontal and a vertical position. So if we were to set it to 0, the horizontal position would be 0, but the vertical would be 100 pixels. So like this. You can set it anywhere you want, just by changing those numbers. And you'll see in the next lecture that it can also be dynamic. Now, we can make this position dynamic, so we can set an X and Y position. In order to do that, let's create an object. So the object is our player, which has an X position and a Y position. You want to create a new object. So we create a new player object from the class player, and then we can say player.x and player.y, and we can increase that value each iteration. Now you'll see that when we run it, You need to use self.player because it's part of the class. And you'll see it's moving around. Now, of course, you can also do that for Y. So you'll see it's dynamic, and you can even link it to keyboard input so that when you press keys, it starts moving around. And you can fetch keyboard input using the function pygame.key.keyPressed or getPressed. This function will return which key is currently pressed. Then you can iterate over it like this. So we're fetching the cursor keys, and depending on which key is pressed, it will output right, left, up or down. So that's how you would do it. So make sure to call the getPressed function, and then you have the right, left and up, down keys. So now you can press those keys. You'll see it doesn't stop, so it just remembers the last key press. Now, once something is pressed, you can start modifying the position of the image. So we can say self.player.x plus is 1, minus 1. You can do the same thing for the like this. So now we can move the image around just by pressing the cursor keys. Now, one thing to notice is that those brackets around it are not necessary. So we can remove those. And besides the cursor keys, you can basically fetch any key from the keyboard. And so we can say if keys K capital, and you'll see we can take numeric keys, the A key, special keys, B key, C, backslash, currency, comma, and basically any key on your keyboard you can select from there. Now I'm using Visual Studio Code, which has a recommendation, which is the same in PyCharm. If you use another program to write Python code, you might not have this recommendation list, but basically you can fetch any of your keyboard keys. For example, we can take the A key and output A whenever it's pressed. So now whenever we press A, you'll see A appearing in the terminal. And this works for any key, right? So it can be also key, for example, key B. And then our program will start interacting for both keys. So you see when I press B, B is appearing. When I press A, A is appearing. And the cursor keys still work. So you can fetch any key of the keyboard. Now let's create a snake or a snake game. So I've added an image called snake.png. So I'll change the image here to snake, and our variable name cat doesn't make sense in this case. So I'll rename this as well. And now run the program. And you'll see I use another image format, not JPEG but PNG. And PyGame supports many different image formats, regardless of whether you have a portable network graphics, PNG, or a JPEG image, or another type of image format. So we have a little circle here that could be the start of our snake. Now, one thing to know with the snake game is that once you press a key, it just keeps moving, right? You are not, when you don't press a key, it's still moving. And so in order to achieve that, we can create a direction variable. So I'll name it D for direction. And depending on the direction, it just will keep moving. So instead of immediately moving the image position, it will change the direction. So we can change this, and we'll be setting the direction. So these numbers will represent right, left, up, and down. And then based on the direction variable, it will start moving. So if it's equal to 1, it's should go left. If should be able to go up as well. Okay, so this looks a bit cryptic, but basically what we're doing is changing a variable, the variable d for direction, whenever a key is pressed, and then regardless of the input, it should start updating. Now, one thing you'll see is that, actually this should just work, so let me try. And you'll see it's moving automatically, even when I don't press anything, but really, really fast. And in order to prevent the game from going too fast, what nearly always happens is that they put a delay in there, in the running loop or in the game loop, where because of the delay, it's not going lightning fast. So to do that, we import the time module, because the time has a function called sleep, which just delays the program. So we can say with every loop, just delay a certain amount of seconds. So let's say we have 1 second delay. And you'll see it's moving every second. Now that might be a bit slower than you want. So maybe 0.1. And you'll see it's moving around. Might even do it like a shorter delay. But you want a delay in there usually in order to manage the game speed. So now you'll see it's moving just on very small micro positions. So it's moving pixel by pixel. What happens in the snake game is that it's using the old positions and it draws the same image on the old positions. And you don't want those to be overlapping. That's why you want to increase by the image size. Now in this case, the image size is 44, which just happens to be the image size. Now you can, of course, can take any image size you want. And you'll see now it's like super fast. You can delay it more. And you see it starts to move around. Next, you want to store the old positions. And in order to do that, we can just say create an array of positions, part of the player class. And in this positions array, we will store the old positions. So in every loop, we know the snake is moving. So we can just append to the positions. Sorry, player. And we'll append both the X and Y position. So that way we'll store the old positions. And then we need to draw that as well. So instead of just drawing one position, we want to draw every position. We can comment this line and draw on the positions. And if we run it, you see we start seeing a snake here. However, it does have an indefinite length. So normally what happens in the snake game is that the length of the snake grows with every apple it eats. Now in this case there are no apples yet. However, we should be able to set the length. So what we'll do is we'll set a length of the snake. For example, the snake length is 5. And then we only draw, or we only append the amount of times that are allowed. So in this case, one way to do it is just to draw the last 5 positions. So in this case, we're drawing all of the positions, but you could say just only draw the last 5 positions. Another way to do it is to only allow 5 positions for the snake. So you'll see we add a new position each time. So another way you can do is to limit that, which might be a better way than to draw, because that way the positions that we're drawing actually exist, instead of having more positions that are not drawn. That makes less sense. So it makes more sense to just have positions that are actually part of the snake. And so we can say if the length of the positions is smaller than the allowed length, then append it. So that will limit the length. However, it only does that for 5 positions, and then it doesn't do that anymore because the length is greater than 5. So what you want to do in that case is to remove the old position. So remove the old position and add the latest position. So in this way, so whenever the length of the snake is smaller than the allowed length, it adds that position, the latest position, to the snake, to the list of positions. Otherwise, remove the first position from the list, because that's the oldest position. So remove the oldest position from the list and add the latest position. So that way the snake is only ever the size of the allowed length. And if we run it, you'll see the snake doesn't get any bigger than 5 in this case, because that's the allowed length we set, right? So if we were to set that to a larger number, let's say 15, you see that the snake grows to a size of 15, but it doesn't grow any longer than that. So that's an easy way to limit the length of the snake. And in the game of snake, you always start with a length of 1 or 2, maybe 3. Probably not 1, because then you have just a dot, right? So maybe a length of 3 or 4 is the basic length, let's say 4. So that could be a good starting point. And then each time we eat an apple, the snake should grow. The next thing you want to do is to add some gameplay. So you want there to be an apple, and in order to draw one, we'll just define one. So that will create the image, and let's also draw it. So put it randomly somewhere on the screen. Let's say 100 by 100. Run the program. And we don't see anything. And that's because we need to blit not on the image itself, but on the display. So change that to display and run it. Sorry, it's display surface. Run it, and you'll see snake image. However, we want to show the apple image. So now it's showing an apple on the screen. And this can be on any position, right? So it can be on 100 by 100 or any position. Now the position should be random. It shouldn't just be hard-coded. So in order to get some level of randomness, we use a module called random, and specifically a function called randint. Now we can get an x and y position for our apple. So we can use randint. Now it can be any number. So for example, any number below 640 and any number below 480. Now when we run the program, you'll see it needs the starting of the randint. So the numbers between 0 and 480 and between 0 and 640. If we run it, you'll see it's randomly putting the apple everywhere. So you want to set the apple position, but not every repetition, right? Not every time you draw the screen. So one thing you probably want to do is to create a class for our apple with x and y. Then create an apple object. And perhaps on the initialization phase, you want to set the position. So self.apple.x and self.apple.y. So we get a new position when the game starts, and we will use that position to draw. Now if you run the program, you'll see it's randomly put on a new position whenever the game starts. Next, we want something happens, that when there's a collision, so when the player or the snake collides with the apple. In order to do that, we need to have a collision function. So I've created this one, and this detects the positions between the snake x and y and the apple x and y, and it should include the size factor. So let me just add it in the game class, and then we can start checking for a collision. So whenever there's a repetition, we can start checking. You can also check on execute function, which may be better. That render is just for rendering the screen, right? That's better to have that separation. So we have some game logic here, so we can add it. So if self.isCollision, we need the first x, the first y, oh, forgot a dot, the second x, the second y, and the size. Now in this case the size is 44, and if that happens we just output collides. Now we can run the program and try to collide with the apple, and you saw we had a collision twice. And so whenever there's a collision, you want to set a new position for your apple. We copy this, new position for your apple, and we want the size of the snake to grow. So now we should have a basic snake game. Yeah, so whenever we see it's growing, now it put it all the way on the edge, which is not probably something you don't want. So you might want to limit the size a bit, and you probably also don't want these random numbers showing up, right? So we have 640 here twice, and it's much better to just keep the size values of the game, or in this case the screen. So let's add a game height and width, and use those variables. Now make sure to not have a typo. There should be a self there, as it's part of the class. Now, if we run it, you'll see we have the snake game. However, there are situations in which it doesn't collide. And that happens because the snake, while it's put in a sort of grid based on 44 size, which is the size of the image, the same is not applied to the apple, right? The apple is just placed on a random position between 0 and the height and the width. So what you can do is just to pick a number of your grid, for example 10 by 10, and then that times the size of your grid. So grid size, in this case 44, and you can multiply that by the grid size. That's where you can never have the situation in which there is no collision. So should add self again because it's part of the class. So now we can play the game, and you'll see it starts to feel like snake. However, there still is no losing possibility in the game. So while the snake gets longer and it starts eating the apples, it's impossible to lose in this game right now. And so that's something you might want to add, because at this moment you cannot lose. So in order to be able to lose, you want at least that the positions are greater than the length of the minimum length of the snake. Then what you can do is use the same isCollision function. However, as parameters, we'll let it check if it collided with itself. So we loop over the length of the player, of the snake, and then we check for collisions. And if there is a collision, it just is a game over. So notice we use the index variable here until the player length. Then we use the isCollision function to check if the current position of the player, so that the head of the snake, collides with any of the positions of the previous positions. Now I've made the collision size a bit smaller, otherwise there was some issue. However, if the collision happens, it will just output game over and exits. So you'll see in both cases whenever you have a sprite or anything in the game, you can use the isCollision function that I've defined above here. So this function to check whether there is a collision. And if there is a collision, whether it's true, you can execute some code. So in this case, there's a collision with an apple, and you execute some code. And in the case here, there's a collision with itself, the head of the snake, with any part of its body. So if you run this program, you see we can start playing the game. The snake gets longer. Let me just make it a bit longer. And now I can make a collision, and you'll see it outputs game over. So you can also delete this debug output. Oh, I've already done that. And you'll see that now we have the snake game because there's a way to lose in the game. So you can play the game yourself. Of course, there's some tweaking you can do. For example, you can output scores for the game. You might want to do other tweaking. For example, in the code base, it starts to look like a really long code. And you see the code gets really long. So you might want to split it up into smaller functions. So it's always a good idea to split up long code into smaller chunks or into smaller functions. Now in the beginning we kind of have that, right? We have some classes and some functions here, which is easy to read. But then as you go on, you'll see the render function still it's okay. However, the onExecute function becomes a really large code. So what you want to do is to split that up into one or more methods or functions. And in the case we are programming in a class, so that's a method. So we can add a method here for handling the game logic. So it's something we could do. And we can copy all the game logic. And put it in the game logic function. Now, of course, we should call the game logic function then here. And make sure that the indentation is still valid. And you see we can still run the program. Still run the program. However, the code base just got a little bit cleaner. So you always want, whenever you have a long piece of code, you want to split that up into more than one function. So for example, we can create a function snake logic where we put in all the logic related to the snake. And for these collisions are really related with the game, right? So that can be the gameplay logic. Now the naming is very important when you're writing programs. So let me just remove that and put that here. So you'll see the code base becomes easier to read with smaller functions, right? You can just look at it. Oh, with the game logic, it's doing the snake logic and the gameplay logic. And of course, you can further split it up to have a really clean code base. Now we have some code here for the events. You can create a function for the event logic. So we can copy all of this stuff in the function handle events. And make sure the indentation is right. And you'll see that now this becomes a lot easier to read. Right, so it still works. You can still play the game. And however, the code becomes a lot easier to read. So whenever we have the onExecute method, we'll see it just does 3 steps: handle events, game logic, and render. And then when you need something specific like the handle events, you can just grab the code you need. Or in this case of the game logic, you'll see it's the snake logic and the gameplay logic. So depending on what you need, you can jump right to the function. So whenever you have a big function or a big method, you should always split it up into smaller functions because it's much easier to understand and to maintain. If your file starts to get very large, so in this case the file is not that large with 125 lines, 124, but you can imagine as you write more code, you get a file of like thousands of lines, and you can split your file into multiple files. And for example, start splitting your classes into several files. Now PyGame supports fonts, so you can also show text inside your game. You can use system fonts depending on your operating system, for example Arial, Helvetica or Verdana. We call pygame.font.sysfont, and you can specify which font you want and the size of the font. Then you can render certain fonts. So you'll see we call the .render function on whichever font we have. So in this case dialog font, we call the render method with the text and also with the color in red, green, blue values. Now these values are between 0 and 255, and the combination of these 3 values of the red, green and blue values make up the color. And you can do this for any of your fonts, and make sure also to draw the font to the screen, and you'll see that it shows the text on the screen. So you can download this example, and you can also include, for example, the score in your game. So to show a font in your game, as we shown in the previous code sample, you want to load the system font with any system font you have and the size. Then in your drawing function, you want to render a certain text using that font, where you have the text and the color. And then you display it on the screen. So you'll see it returns a surface or a sprite at a certain position. And if you were to run this, you would see the text on the screen. So right at the bottom where I put it. Now, of course, you can put that text anywhere you want. However, I didn't want it to be on top of the snake immediately when running the game. So that's why I put it at the bottom. You can put it, for example, at position 0, which is the top of the screen. However, then it immediately overlaps.